Hello. In today's lesson, we are looking at part A of question 16, 2018 extension to mathematics. Use mathematical induction to prove that for n greater than 1, x to the power of 3 to the n minus 1 is equal to x minus 1 in the bracket times the new bracket x squared plus x plus 1, and the third bracket x to the 6 plus x to the 3 plus 1, dot dot dot. This bracket continues until we hit the last bracket, which is x to the power of 2 times 3 to the n minus 1 plus x to the power of 3 to the n minus 1 plus 1. So as we do with any induction problem, we start with the assumption that the statement is true for k. So assume true for k. So all we need to do is replace n with k. So you've got x to the 3 to the k minus 1 is equal to x minus 1, x squared plus x plus 1 times x to the 6 plus x cubed plus 1 dot 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 x to the power of bracket 2 times 3 to the k minus 1 plus x to the 3k minus 1 plus 1. So that is if we assume that the statement is true for k. Now we need to prove that the statement is true for k plus 1. Before doing that, it's a good idea to see what is that we are trying to prove. So if we write a statement for k plus 1 will look like this. Just replace k with k plus 1. So x to the 3k plus 1 minus minus 1, that's in the bracket, minus 1 is equal to x minus 1, all these terms, all these expressions, including this, which covers us up to k, but remember we are after k minus 1. And now replace k with k plus 1. So k plus 1 minus 1 just becomes k. So 3 to the k. So x to the power of 2 times 3 to the k plus x, again k plus 1 minus 1 becomes just k plus 1. That is what we are trying to prove using that. All right, let's see how we can go about this. For on the left hand side of that, so let's call this 1. All right, so the left hand side of 1, using the difference of two cubes, a cubed minus b cubed is equal to a minus b times a squared plus ab plus 1. Okay, we're using that. But how does this look like the left-hand side of that? Left-hand side can be written as x to the power of 3 to the power of k plus 1. I can write it as 3 times 3 to the power of k. Okay, that power can be written as in that form because 3 means 3 to the power of 1 and I'm adding them, so I add the powers. Minus 1, then I can rearrange this like that, x to the 3 to the k, 3 to the k, and then to the 3. Remember that when you got two powers, you times the powers together. So if I times that, I'm going to get that. Minus 1. Okay, now I've got this form because 1 cube is the same as 1 and this is equal to that which is in the cubic form. So my A is now x to the power of 3 to the k and my B is 1. So that becomes x to the power of 3k minus 1. That's A, that's B. Then a squared. A squared becomes x to the power of 2 times 3k. Plus a times b, so that becomes x to the power of 3 to the k plus 1. All right, so we wanted to prove this, we want to prove that number 1, relationship number 1. And so far on the left hand side we showed that this can be written in this form. Now if you look here, this is the same as the assumption. Alright, so using the assumption and replacing for this, we have this. Okay, so x to the 3 to the k minus 1 is equal to that based on the assumption. And I have x to the 3k minus 1. I have the same thing here. So I can write this as x minus 1, x squared plus x plus 1, and x to the 6 plus x cubed plus 1 dot 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 x to the power of 2 times 3 to the k minus 1 plus x to the power of 3k minus 1 plus 1. Okay, so that covers me up to here, and I add the next bit. X to the power of 2 times 3k plus x to the 3k plus 1. All right, and that is basically what we wanted to prove. Okay, so now we end up with the right hand side of 1. Okay, so the statement, if you want here you can write using the assumption. So to show that how you end up with that, we use the assumption to end up with that. And now if we look, we call this equation 2. So a better way of putting that, so the equation number 2 shows that the statement is true for k plus 1. So, by mathematical induction, true for all. Induction, it is true for n greater or equal to 1. Thank you for your attention.